Today, we're going to talk about a tool to compare how experts rate carbohydrate foods. My name is Josh Marino. I'm a bioengineer by training, where I studied regeneration and inflammation-driven disease pathology in a dish before transitioning into biostatistics and nutrition during my F32 Brain Initiative-funded postdoc at Tufts University. While I was there, I worked on the statistical models and algorithms for both the Global Dietary Database and the Food Compass projects. Over the last 3 years, I've been stumbling along in an entrepreneurial capacity as the founder of Bespoke, which aims to make science more accessible and actionable by developing tools that help support better health decisions. I have 2 disclosures to make. The first is that I've previously received a research contract in 2021 from the Florida Department of Citrus, and I'm the of Bespoke. I want to start with a picture of where we're going to end up today. You'll learn about what a meta-nutritional profiling system is, why it was created, what problem it solves, and how to use the interactive tool and database to simultaneously ask your research questions and receive consensus-driven food health information for carbohydrate-rich foods. We're going to skirt over a lot of technical details today, so I really encourage you to check out our published paper in the International Journal of Food Sciences and Nutrition for more information. This webinar covers 3 main objectives, from background knowledge to learning about the nuts and bolts of how to use this interactive tool for research or general purposes. And it's really important that you should tune into the next webinar of this series to learn more about specific types of insights that this tool provides. The first objective focuses on this idea of harmonized expert ratings and includes some technical details to give you some intuition for how it works behind the scenes. You may have heard of the terms nutrition profiling systems or nutrient density before. Essentially, these are all algorithms created by experts with the goal of defining and quantifying food healthfulness. We started this work by selecting a diverse list of individual NPSs, including the nutrient-rich food systems, the food compass, the food processing score, and Nutri-Score. We then codified them all into the same statistical format, essentially a score from 1 to 100, with 100 being the most healthy, and evaluated the food supply, which was 6,500 foods in a database known as FNDD. And then we plotted the results all the way on the right. And I think one thing you can visually appreciate from this density chart is how globally heterogeneous the health scores using these various definitions are. I remember kind of just staring at the screen for a little while when I first saw this pop up on my code viewer, trying to make sense of what was happening. And then I realized the central problem is that there are too many health scores and definitions of healthy, and we don't currently have a scientific method to evaluate their accuracy. It's like the wild west for food health, and consumers and decision makers are not well equipped for battle. And so our solution was to establish a framework and interactive tool to kind of harmonize these disparate scoring systems, and in doing so, to highlight the circumstances surrounding the potential sources and key areas of disagreement. And that's really why this meta NPS was created. The innovation that was developed is using consensus as a way to harmonize these systems. Pretty much everything on the right-hand side beyond the individual nutrient profiling systems. And to our knowledge, comparative food healthfulness has not yet been considered in the more general context of meta-science, and we believe we're establishing new statistical meta-methodologies that could also apply elsewhere. For example, in the emerging field of polygenetic risk scores and heterogeneous individual level disease risk seems to have a lot of parallels. In any case, let's take a look at the key components of a meta-NPS, keeping in mind that nearly every process, cut point, or analytical decision is like wet cement at this early stage, and I'm open to thoughts on how to improve it. So a meta-NPS for any given food, for example, whole wheat bread, has a meta-score, which is defined for the sake of today's talk as the median score across all of the systems. And it accounts for the consensus of the score, something that we are referring to as the score stability. And an overall index known as the Food Recommendation Index, which consolidates these two aspects of the meta-NPS. This tool can be helpful for a variety of applications and use cases. For example, if you're in clinical practice, rate foods in a food retail system, or a researcher using rating system to design or interpret studies, or even a health-conscious individual, the meta system gives you an overall score across 5 unique systems, and eventually as many as we want to include, and lets you know where there's expert disagreement. For people managing a food rating system, this tool provides metrics to help you identify gaps in which your ratings may differ systematically from others, which highlights an opportunity to seek consensus between these individuals and their systems. Zooming in a little bit, we're taking a look now at a healthfulness box plot. Each dot on this chart indicates 12th percentile rating from one of the expert systems. For example, whole wheat bread has ratings ranging from about the bottom 10 all the way up to around the 100th percentile. In other words, it's either unhealthy or very healthy, depending on who you ask. And it's worth mentioning that we've only sampled a small fraction of possible scores that exist, but we believe our sampling was sufficiently diverse enough, geographically, statistically wise, to get started. Obviously, the inclusion of selected individual NPS has implications for the downstream applications, similar to any other meta type of analysis. More details regarding the selections are provided in the brochure at the beginning of the webinar. And importantly, this flexible framework can accommodate many additional iterations. A metascore is a proxy of these health scores, which higher or lower values indicating more or less healthy, respectively. Similarly, we believe health consensus is desirable for fair decision-making, and we are taking a democratic approach to health consensus. Now that you have an intuition for the components of the meta-NPS, let's take a look at a new user interface we've developed, which leverages our overall healthfulness measure, the Food Recommendation Index, and consumption patterns. In the center of your screen, we have a healthfulness impact chart showing whole wheat bread as an example with some meta-NPS summary statistics. The arrows convey information regarding our tentative cutoffs and their interpretations. I want to give some context for how to interpret each axis of this chart. First, the x-axis, health impact, is pretty straightforward. It's the consumption of the food measured as the average grams of carbohydrates per day. This was estimated from dietary records of individuals aged 4 and up using NHANES data. The y-axis, healthfulness, is derived from components of the meta-NPS. So this healthfulness measure is what we previously called the Food Recommendation Index. It's a proxy of healthfulness that identifies foods that are consistently rated as healthy. Essentially, the FRI allows us to collapse the nuance of the meta-NPS distribution for a single food into a single point. The FRI combines the metascore, which is a proxy of health scores rated by multiple experts, and stability, which is a proxy of health consensus. Put it all together, we can say that whole wheat bread is uncertainly healthful and moderately impactful. In other words, it's somewhere in the central region of this chart. Zooming out a little bit and looking at more than just whole wheat bread, now we see that each dot is one of 122 of the most commonly consumed carbohydrate-rich foods in the United States. The colors are mapped to the level 1 food categories present in the database. And now what we're going to do with this chart is start to overlay some key healthfulness regions to help improve the interpretation. First, as an illustrative cutoff, anything toward the top 25 points of the FRI will contain certainly healthy foods. Those that have both a high metascore and a high stability, consensus, and certainty. Next, any food underneath the bottom 15 points of the FRI will contain certainly unhealthy foods, those with a low metascore and a high stability, consensus, and certainty. A lower range for this category was chosen because it's more likely that foods with higher uncertainty also have a lower FRI. In the middle, we have foods that are neutral, somewhere with a metascore in the middle, but high stability, and those that are uncertain. So they either have a low or high metascore, but they have low stability and high uncertainty. Now we're going to take a second to show you a step-by-step tutorial on how to actually, and demo on how to use the interactive meta-NPS. So I'm going to switch my screen now to the actual tool in place of the slides. And so now we're looking at our healthfulness impact chart, the same thing that was just on the slides before. And you can see as I scroll over various foods that all of their meta-NPS statistics pop up. On the bottom hand, we have each food listed with a number of summary statistics, anywhere between the category it's involved in, the grams of carbohydrate, usual intake of the food, the food recommendation index using a stability measure on the interquartile range, the metascore, the stability score by itself, the min and max values, and their respective systems that they belong to. These two components are bidirectionally linked. So if I go to whole wheat bread, for example, and I drag and drop a box around it, you can see that it updates the database on the bottom. When you double click on the chart, you reset the beginning to go back to where we started, and you can go back the other way around. So I can say, let's look for whole wheat bread. And there's two varieties of whole wheat bread, and what we can do is, select both of them in this table down here, and you'll see it pop up top. That's all well and good. There's also an additional interactive layer here in the legend, so we can double click on elements of the legend. Let's look at desserts, for example, and that will filter the database for only the food groups that are shown here. So now if we wanted to find the dessert with the most healthfulness, we can just go and look and say it's pan dulce. The idea. We can also now overlay an additional food category on there. Let's go for fruits and vegetables. And you see that fruits and vegetables, in contrast to desserts, are much tending towards the higher level of healthfulness. And to reset, to get to where we go, like I said, you just double click on the center. For the food legends, it's a little tricky. You kind of have to double click until you get back out. But that's essentially the nuts and bolts for how this works. You can go beyond just a single food, and if you wanted to do a selection of foods, some that are pretty uncertain and have a moderate level of impact, you can create a box like that, and then you can kind of go through and see, are there interesting foods that you want to look down here to get a better look for where they at. So corn tortilla. We mentioned that it's bidirectionally linked with the database. It's filtered on click. And to summarize, we've introduced the meta-NPS as a bridge between science and food health information. A user can query this tool with a number of questions about specific foods, which references in the back end a harmonized, consensus-driven expert rating database before returning the relevant healthfulness attributes specific to that food and their research question. I would like to acknowledge several of my friends and collaborators who have contributed over the years to making this work more likely to have an impact across science, food, and health. And please reach out to me by email, LinkedIn message, or through our website with any questions, comments, or insights. And thank you for your time.